Now let's take a look at it from the other way around. Instead of being given a graph, we're going to be given a situation and we have to graph it. So it says Professor Splash set the world record with a 36-foot belly flop into a 1-foot pool of water. Sketch a graph of his height over time. Sketch a graph. First thing we want to do is we want to put our X and our Y axes just by putting a line. We want to label them. So let's think about this. What are our variables? Our variables would be distance, and our other variable would be time. Which one depends on the other? Well, the distance in the air that Professor Splash would be depends on the time, meaning time is our independent variable and distance is our dependent. 9 out of 10 times, maybe even more, time is going to be an independent variable because we don't have control over it. So time goes here. Distance goes here. I'm sorry, I shouldn't say here. I should say time goes on the x-axis. Distance goes on the y-axis. Now, there is a big difference in math between the word sketch and the word draw. Sketch means to estimate, it doesn't have to be exact. Draw means to actually be exact with this. So we don't have to worry about that. Now, we know that he starts at 0 time and his top height is 36 feet. Well, what would the distance look like over time? Would he be going higher up? Would he be going higher down or lower? And if you think about it, if he's jumping and doing a belly flop, over time, his distance is decreasing. So the rough sketch that we would provide would look something similar to this one right here. Just showing a steady decrease over time. Now, if we actually had to draw it, we'd have to be more specific. We'd have to find actual data. But here, we're just showing the basic path that he would take.